Welcome back, everybody. This video is going to be talking about quadratic equations and also perfect square equations. Now, we first start out by saying if you have any term squared, so a variable, a number, or any combination thereof, any kind of term, if you square it, the way to undo something squared, or say the opposite, is to take the square root. Likewise, if you have the square root of something, the opposite of that would be to square it. And then we have something squared. So we use the first one here. A lot of our equations today are going to have something squared, and we're going to undo them by taking the square root. Let's start off with this example. 2y squared equals 128. We're going to solve for y. Let me rewrite it here. First thing we're going to do is divide by 2. And then we get y squared equals 64. Alright, and then here's where we take the square root. We got to get y by itself. It's being squared. We take the square root of it, but if I do take the square root of one side, I got to take the square root of the other side. And the square root of 64 is 8, but we also have to consider the positive and negative possibility. If I take 8 squared, I get 64, but if I take negative 8 squared, I also get 64. So therefore, we have two answers. You could always have, for a quadratic equation, you can always have up to two answers, usually the positive and negative of a number, but it depends. Sometimes it's different. Let's look at another one here, and this one's going to be a little bit different. 8g squared minus 3 equals 2. And we're going to add 3 to both sides. And that gives us 8g squared equals 5. Next step, try to get g by itself by dividing by 8. G squared is going to equal 5 over 8. And then here we are taking the square root again. The square root of both sides. G is going to equal plus or minus the square root of 5 over 8. Now here's the thing. Really can't have the square root of a fraction, and here's why. If g equals plus or minus the square root of 5/8, that could be rewritten as square root of 5 over square root of 8. And we are definitely not allowed to have a radical sign or square root sign in the denominator. So here's what we're going to do. We're going to multiply it by 1. But we're going to rewrite 1 a different way. G still equals plus or minus square root of 5 over square root of 8. But I'm rewriting 1 as the square root of 8 over the square root of 8. The reason I do that is I'm performing an operation called rationalizing the denominator. Rationalizing the denominator gets rid of a radical sign or a square root symbol in the denominator. Notice what I have going on here. Square root of 8 times square root of 8. Well, that equals plus or minus square root of 64. And in the numerator I have 5 times 8 square root of 40. Alright, rewriting again. The square root of 64 is 8. So I got rid of the radical sign in the denominator. But I have square root of 4 times 10 in the numerator. I can rewrite 40 times 4 times 10. And I can take the square root of 4 to get 2. And I have 2 square root of 10 over 8. And then the 2 over 8 can reduce to 1 over 4. Not having to write the 1, I end up with square root of 10 over 4. So, two answers to what g equals plus or minus square root of 10 over 4. This is the simplified version of the answer. Now I have a plus 12 quantity squared equals 81. Notice this time the quantity is squared. In order to undo the square, take the square root. And now that gives us a plus 12 by itself. Square root of 81 is 9, but there's always the plus or minus possibility. When you have a situation like this, break it into two mini equations. A plus 12 can equal 9, or a plus 12 can equal negative 9. I'm going to take away 12 from both sides on both equations. Here, this a equals negative 3. Here, this a equals negative 21. A equals negative 3, or a equals negative 21. All right, now we get into the perfect square equations. We have d squared minus 10d plus 25. This follows the format a squared minus 2ab plus b squared. When we have a perfect square trinomial like that, it always equals a minus b quantity squared, and that is the factored form. In this problem, I can rewrite the left side of the equation as something minus something, quantity squared, still equal to 49. I determine those somethings. The square root of d squared is just d. The square root of 25 is just 5. So now I have a situation like the previous example. It's quantity d minus 5 squared equals 49. I'm going to take the square root of both sides. D minus 5 is by itself. The square root of 49 is 7, but there's the positive or negative possibility. And now I'll break it into the two mini equations like I did before. D minus 5 equals 7, or d minus 5 equals negative 7. I'm going to add 5 to both sides. Seven and 5 make 12. Negative 7 and 5 make negative 2. Two possible answers for d. D equals 12 or d equals negative 2. Look at one more very similar type problem. Notice we have a perfect square trinomial yet again. Follows this format: a squared plus 2ab plus b squared. That factors into a plus b quantity squared. That's what we have here, perfect square trinomial. We'll set that up as a quantity squared, something plus something equals 50. To find those two somethings, take the square root of b squared and the square root of 100. B squared square root is b, square root of 100 is 10. B plus 10 quantity squared equals 50 is how I can rewrite this equation. I can then take the square root of both sides to undo the squaring. B plus 10 is now by itself, and it equals plus or minus. Remember, when you take the square root of a number, there's always plus or minus square root of 50. To get b by itself, I'll take away 10 from both sides of the equation. B equals negative 10 plus or minus square root of 50. Now, we're still not done. 50 can be simplified. It's not a perfect square number, but it can be simplified. We have negative 10 plus or minus. I'm going to rewrite it as 2 times 25, or 25 times 2. I can take the square root of 25, but not 2. The square root of 25 is 5, and I'll write that out in front for final answer. B equals negative 10 plus or minus 5 times the square root of 2. That's our final answer. All right, thank you for watching. Hope this video helped.